just had to rely on y'all to watch the 1/20/24 8.1. I recorded, it said it recorded an hour and 20 minutes, but it only had like the last 5 seconds of class. So I don't know what happened there. I don't know if somebody messed with the recording or try not to touch stop recording. Don't hit that, okay? Because I don't know why it did that. Okay. First of all, some announcements. Go ahead and write this down. The last day of class is Tuesday, November 24th. This was for yesterday, so we're not going to do that. This class meets on Tuesday and Thursday. So therefore, your last day of class, we got 3 classes left. Today, Thursday, and Tuesday. I think I have already changed the homework and the test for that because we're not going to get to chapter 10. All right. Your project will be due on the 24th. On Tuesday, the 24th, you will send me what you have of your project. Hopefully it's nice and typed up and got some graphs and shows your work and all that. Just put it on a scanner and send me via email. Please put in the subject line, Math 120/29, project due. Please put the 120/29. I beg you, please put the 120/29, because that way I can put all your work in your 120/29 folder and I can print it out at one time. If you don't send me 120/29, I'm going to have to look you up and I'm going to have to find out which class you're in. Okay, so please don't do that. Please put 120/29 project in the subject line and just attach it. If you do it all in Word documents and Excel, then just send those attachments. But I would rather you have it all in one, thing. Okay, if you're going to just try to make it as simple as possible, but I do want it to be pretty so I can have it in a folder. So if any of these bureaucrats want it, they can look at it. Okay. 10% of your grade. On Tuesday, the 24th, also, your final exam and your last test will start. Homework will terminate on the 24th. Okay. The final exam and last test will start and it will end on midnight, December 7th. The last test in this class will cover up to 9.2, 8.1, 8.2, 9.1, 9.2. Okay. I'm going to write it on here because I'm going to be talking to other classes and I don't want to put those sections on there. Okay. The last test will cover whatever material I cover up to 11/24. And this class is probably going to be either 9.1 or 9.2. For whatever. Okay. Now, what's on the final exam? The final exam, you will have 2 attempts. Takes the highest of the 2. I better write that down because somebody's going to screw that up. Higher of the 2. Okay. Usually 25 to 33 questions, 25 or 33. I usually use those two because they're evenly divisible into 100, and it's a good quantity of questions. If you want to review your old test, you can do that through the grade book. Hit grade book and go to the test, and there'll be a link out there where you can hit review. So you can go over all your old tests. You will have 2 hours to take the test. Even though it's an hour test, I give you double the time. So I make the test an hour, so you'll have double the time. I could make it a 2-hour test if you want me to, but I choose to make it a 1-hour test, and you have double the time. And the final exam will start on 11/24, and it will end on 12/7, 8 a.m. and midnight. Just like all your tests have been starting and ending all semester. Nothing's going to change. Also, if you see something funny on My Labs Plus, just go with it. Let me ask you a question. If I was to give y'all a hard copy test and I grade it, hold on a second. I got one of my cats trying to drive me crazy this morning. Okay. And I give you a hard copy test and I grade it, and I give you your test back and everybody got an extra 10 points. Is everybody going to raise their hand and say, Hubert, you gave us an extra 10 points? Is everybody going to do that, or is everybody going to keep their mouth shut?
We're all going to keep our mouths shut.
Exactly. So if you see something on My Labs Plus and it benefits you, don't write me an email and say I'm confused. Go with it. All right. So let's go over everything again. So that way I don't have anybody asking me all these questions, these hammy questions. Last day of class is the 24th. We got 3 classes left. In those 3 classes, I'm going to try to get to 9.2. I know I'm not going to get to 10, so I'm just going to get to 9.2. Tuesday the 24th, your project is due. Make sure you send it to me via email and put it in the subject line, Math 120 29 project. Please put the section, Math 120-29 project. On Tuesday the 24th, your final exam and your last test, which will be 8.1, 8.2, 9.1, 9.2, will start. They will end on December the 7th. Homework will terminate on 11/24. The last test will cover whatever material I cover up until Tuesday. Chances are it'll be 9.2. The final exam, you will have 2 attempts. I'll take the higher of the 2 grades. If you make a 98 and you choose not to take it, then that'll be a 98 and a 0. I'll take the 98. If you have a 98 and a 72, I'll take the 98. You will have 25 or 33 questions. These will be all bonus, all math questions, no bonus questions. They will come from the old test. If you want to look at your old test, you go through the grade book and hit review. You will have 2 hours to take the final exam. Only make it about an hour, so that way everybody has double time. I could make it a 2-hour test, but I'm not. And it will start at 8 a.m. on 11/24 along with your last test, and it will end on 12/7. And if you see something funny on My Labs Plus in the next few days, and it looks like it will help you, take advantage of it. Don't send me an email that say I'm confused. Go with it. Any questions? Does that ask all the Hemi questions, all those people that spaz out at the end of the semester? Does that answer most of them?
Yeah, I just have a question. So we basically have to have the final exam and the last test by the 7th, December 7th.
Yes, you got 2 weeks to do both. Because technically it cuts off on the 24th. I mean, it starts on the 24th and ends on the 7th. That's right at 2 weeks, I think. You have to look on the calendar. And My Labs Plus will have those dates on there also. So that way, if you have a question, all you got to do is look on My Labs Plus. Any other questions? That pretty much covers the Hemi questions. Because I know somebody was fixing to ask those questions. I'm just glad I got to them before you asked them. All right. So that takes care of those questions. Now we can focus on finishing. All right. And today we're going to finish with 8.2. Now 8.2 is going to, it's not very difficult. It's going to focus itself around P hat. So you might want to highlight P hat because that's what it focuses, that's what it's, all the information on 8.2 is focused around P hat. What is P hat? Well, P hat, wait a minute, that's the wrong handout. P hat is X over N. Okay? X over N. If I give you an example on a test or a homework problem, I'll say, I've got 200 workers and 150 are sick. So what is P hat? P hat is going to be 150 over 200. Remember, N is always what? What have I told you since the first week of class? N is always your what? N is always your what number?
Isn't it like your new number?
No, it's always the biggest number. It's always your biggest number. I thought I told y'all that. It's always your biggest number. So if you got two numbers, then N is going to be your biggest number. Okay? So 200 is your biggest number and 150 is your X. And you plug that in and you get 0.75. Q hat is the complement of P hat. I told you this in chapter 6. I think it was chapter 6. I told you that Q is always the complement of P. Well, Q hat is the complement of P hat. So if P hat is 0.75, Q hat is going to be 0.25. Now you're going to use P hat and Q hat in different formulas, and you'll see that in just a second, as well as chapter 9. Now, you also may be given P hat in terms of a fraction or a decimal or a percent. Most of the time, you will turn those into a decimal for calculations. Okay, sometimes you'll be given a question like this. You have 200 workers and 150 are sick. Find P hat. And you plug in 200 and 150 and you get a decimal. Sometimes you'll be given a percentage. 25% of the workforce has the measles. What is P hat? P hat is 0.25. The question gave you a percent instead of numbers. So they're going to give you numbers. They're going to give you a percent. Sometimes they'll give you a fraction. Sometimes they'll give you a decimal. All of those need to be turned into a decimal when you're working with p hat, when you're plugging it in formulas in the future. Okay. That's basically what 8.2 is. When one other formula, but we'll go over that in just a second. Also, p hat, also you got to remember in 8.2 about your normal curve. Everything focuses around the what? The center. Whether it's a median or a mid-range or a mean, usually in some way, some form, everything is compared to the center. And that's why you have a normal curve. You have skewed right, which all the data is on the left of center. And you have skewed right, which all the data is to the right of center. I'm sorry, skewed left, which all the data is to the right of center. And remember, your large number rule, if you have a big N, then that means you have less, the standard deviation is going to be small. The larger the N, the less the standard deviation should be. Spread, standard deviation, same thing. Okay. And the last little piece of information. We know that p hat is equal to x over n, and q hat is 1 minus p hat. It's the complement of p hat. And here is your formula for standard deviation. And this is basically from chapter 6. They just put p hat in there instead of p. P hat times q hat over n. Take the square root of that. So of course the variance is p hat q hat over n without the square root. Now there's a couple of little things over here you need to remember about n. N is always, little n is always less than 5% of big N. And if you take NPQ and multiply them together, it should be greater than or equal to 10. Now, most of the time that's going to happen. In other words, most of your problems that you're going to be given on the homework and the test will fit those two. Okay. And the mean is equal to P, and we'll get into that later in chapter 9. Now that's basically, excuse me, that's basically 8.2. Now what I'm going to do now is we're going to go into 8.2, and I'm going to pull up the slides, and we're going to look at some of the questions that they give us. And that's not one of them. And I'm at the wrong, there. And that's p hat. There's an example right here, and I want you to write it down because I want you to see that they can give you a big, long, wordy paragraph, and it'd be real simple. In a Quinnipiac University poll conducted in May of 2008, 1,745 registered voters nationwide were asked whether they approved of the way Bush was handling the economy. 349 responded yes. Find p hat. P hat is equal to 349 over 1745. So therefore, q hat would be 0.8. I want you to get used to writing p hat and q hat. because it's very important that you understand that they are the complement of each other. So in this case, P hat is equal to 349 over 1745, which is equal to 0.2. Therefore, Q hat is equal to 0.8. Now, you may not need that in the homework or the test question, but it's always nice if you're thinking in terms of the complement. This time, they say, according to a, and don't worry about the bottom part, it says, according to a time poll conducted, 42% of registered voters believe that gay and lesbian couples should be allowed to marry. In this case, P hat is 0.2. So you would just write down, don't worry about the second part because I'm not going to worry about that. Okay, in this example, P hat is equal to 0.42. Therefore, Q hat is equal to 0.58. And see, they gave you a percentage. They didn't give you a number, they gave you a percentage. And you turned it into a decimal. So they could give you one like that.
I have a question.
Yes.
How'd you get 0.58?
What is 1 minus 0.42?
Oh, okay, I got you.
Remember, it's always what makes up the whole. Okay? So think of $1 minus 42 cents. If you bought something that cost 42 cents and you paid with $1, how much change would you get back? 58 cents. Same thing here. If you paid for something that cost 20 cents and you paid for $1, you get 80 cents back. Okay, this is what you can write this. You can just ad lib this. We already talked about it. The shape. As n increases, remember the large number rule. Okay, I'm going to write this down because the large number rule applies on this. The large number rule basically says the more you do, the better off you are. Okay? Instead of surveying 50 people, you need to survey 500 people. Instead of running a trial 50 times, you need to run it 500 times. Okay? Laziness does not fit in with probability and statistics. All right? As n increases, that means your research increases. If your research increases, then you are probably going to be more prone to being a normal distribution. The more research you do, the more people you survey, the more apt you're going to get a normal distribution. The mean of the sampling distribution of the sample proportion equals the population proportion. And we said that a while ago. I wrote it down in red. The mean of the population is equal to P. And then the standard deviation of the sampling distribution. Okay, that's what I was telling you a while ago. You can write it down like this. As n increases, your research increases. And I don't know if I spelled that right. And that means that your standard deviation is going to decrease. The more normal you are, the more normal distribution you get, the less the standard deviation is going to be. Remember, what did I tell you standard deviation was? It's the what? The spread. So if the spread is big, that means your research is not good. If the spread is little, that means your research is good. So the higher the number, the better the normal distribution. The higher the number, the less the standard deviation. And that's what this slide is saying. And there, I already gave you that, but I didn't use it 1 minus P. I called it Q hat because that's what the standard deviation of P hat is equal to the square root of PQ over N. And there's the test, one of the tests. NPQ, where's my red marker? Let me find my red marker. NPQ has got to be greater than or equal to 10. That's a test. If you multiply NPQ and you get 9, then you can't do the problem. But I can tell you right now that most of your problems are going to be right. They're going to be doable. NPQ is greater than or equal to 10. And there's your other rule. Little n is got to be less than or equal to 5% of big N. One example is registered voters. They're going to give you an example of registered voters. Well, how many people, millions of people in the United States are registered voters? The population of the United States is around 350 million. I think or billion, I can't remember. I think it's million. Okay. Let's say half of those people are adults. Then that's 175 million. Let's say half of those, 180 million, would be what? 90 million? Okay, so we'd say 90 million are registered voters. Okay? Even if you're just estimating, N, whatever your N is, it's got to be 5%, less than 5% of 90 million. Well, 10% of 90 million is 9 million. So 4.5 million, your N has to be less than 4.5 million. Well, sometimes your N is 50. Well, that's going to check. Okay. So like I said, most of the time on your homework and your test, these tests check. Okay. But they'll show you in a couple of examples here in just a second. Here we go right here. According to a time poll conducted in June of 2008, 42% of registered voters believe that blah, 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 blah. So P hat is equal to 0.42. Q hat is equal to 0.58. And N is equal to 50. All right, that's what they give us in this example. All right, let's check the test and see. Well, first of all, I said that there was 7.5 million or something like that. What did I say? 90 million, and half of 90 million was 4.5 million or 45 million. Yeah. Well, 10% of 5% of 90 million, I said was 4.5 million. Yeah. 4.5 million or something like 45 million. I can't remember what I said. But is 50 less than 45 million? Yes. Okay, let's check NPQ. Well, can't we say that NPQ is close, can't we say that P hat and Q hat is close to 0.5? I think we can. Okay, so what's half of 50? 25. And what's half of 25? 12. Is 12 greater than 10? Yes. So both of the tests, even if you estimate both of the tests check. I'm gonna write them over here. I think I said 45 million. 45 million registered voters, that's a guesstimate, times 0.05 is going to be greater or equal to 50. So that checks. And then NPQ 50 times 0.42 times 0.58, I said is 12, and 12 is greater than 10. So the two tests check. Now, of course, they're going to get different numbers because they didn't estimate, just estimated. Since 0.42 and 0.58 are near 0.5, I just took half of 50, which is 25, and then half of 25, which is 12.5. 12.5 is greater than 10, so it checks. Okay, you can take your handy dandy calculator and we can take 50 times 0.42 times 0.58. I said it was going to be 12.5. Now, if you do it by the book, you get 12.18, 12.2. It's still greater than 10. So that's what they're going to do. They're going to check to see. Oh, they went ahead and got, oh, there it is. There's the two tests right here. The sample of N is equal to 50 is smaller than 5% of the population size of all registered voters in the U.S. So they didn't even put a number to it. They just said, common sense wise, 50 is smaller than 5% of the registered voters of the United States. And then they did NPQ, and then they went ahead and got the standard deviation. So let's go ahead and do that. So the standard deviation, let me move this up a little bit. Standard deviation of P is square root N, which is equal to the square root of 0.42 times 0.58 over 50. And let's do that on the calculator. 0.42 times 0.58 divided by 50 and raise that. That's 0.0, let's write that down, 0.004872. Somebody tell me what that is before we put the square root over it. What is that? It's not the standard deviation, it's the what? Starts with a V. A.
Variance.
Thank you. I don't know what I'd do without you, Miss Cameron. I guess be weaned on a pickle like the rest of the class. Take the square root of that, and that's equal to, raise that to the 0.5 power. And that's going to be 0.0698. 0.0698. Look at it this way, Miss Cameron. You're going to have a nice office one day. The rest of these people, they're going to be like in a closet office. So you got that to look forward to. .0698. Let's see what they got. It's a miracle. Okay, let's look at this example. According to the Center for Disease Control and Prevention, 18.8%. There's our p hat. So I'm going to write down here. I'm going to write p hat is equal to 12.1880. Therefore, Q hat, let's find Q hat. Take your handy dandy calculator. 1 minus 0.1880 is 0.8120. Okay, so that's my Q hat. According to blah, 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 blah. Okay, in a random sample, N is equal to 90. So A, N is equal to 90. Well, let's see. In a random sample of school-aged children, 90. So, let's say 6 to 11. Would you say that there's probably 1,200 students in the school? Would you say, you know, what is 6 through 11? What grade is that? I have no earthly idea. My son's 14. So let's say 5th grade, maybe? I don't know. Anybody know? What is 6 through 11?
I think it starts like what, kindergarten through 6th grade, maybe?
Okay. All right. So wouldn't you say there's 1,200 students in a school?
Yeah.
Okay, let's say there's 1,200 students in a school. So 1,200 times 0.05. Well, 10% of 1,200 is 120, and half of 120 is 60. Whew, that's not going to be, so we're not going to worry about that, okay? Because they're not asking that, so we're not going to worry about it. Plus, I probably need to pick a higher, like 1,500. They're not asking that right here. In a random sample of 90 school-aged children, what is the probability that at least 19% are overweight? 19%. So we got to, let's see, we've got a mean of 18.8, and we're going to figure a standard deviation. So standard deviation would be, standard deviation of p hat is going to be equal to square root of P hat Q hat over 90. And that's going to be 0.1880 times 0.810 divided by 90 and take the square root of it. So that's going to be 0.1880 times 0.8120. And we're going to divide that by 90 and raise that to the 0.5 power. I get 0.0412. Now, I think we're going to be using the z-score formula to find a z-score. Hold on a second. Yep, there we go, right here. In A, we're going to find a z-score. So 19%, so we're going to do A right now. Let me back up one. So A says 19%. So 19%, 0.19 minus 0.1880 over 0.0412. And that's going to be our z-score. So, and that's what they're doing right here. And they come out with a z-score of 0.05. So that's our z-score. So if you've got an older calculator, we're going to do second VARS normal CDF of 0.05 to infinity and 0 and 1. And that should be 0.4800, 0.4801, 0.4801, or 48% are going to be whatever they say. Let me get the question. Hold on. There we go. That's not just right, is it? No, that's not the right one. Where is that? 0.4801. There's your. Now ignore this because they're doing the table. Now, if you have a newer calculator, you would say second VARS normal CDF 0.19 to infinity 0.1880 and standard deviation of 0.0412. And enter. And they got 0.4806. Okay. Now let's go back to the question. So A is 0.4801 or 48%. B, let's see what B says before we do it. Suppose a random sample of 90 school-aged children aged 6 to 11 results in 24 overweight children. What might you conclude? Well, 24, you got to get a new P hat. So B we got to get a new p hat. And that's going to be equal to 24 over 90, which is equal to, take your handy dandy calculator, 24 divided by 90. 0.27. Therefore, Q hat is going to be equal to 1 minus second answer, 0.73. So now a new 0.2667, and you're going to use that in your new standard deviation, new z-score. That's going to be, and we'll use 0.2667 since they did. So 0.2 new z-score, 0.2667, or 27%, minus 0.1880 divided by our standard deviation is 0.0412. So take your handy dandy calculator and say 0.2667 minus 0.1880 and divide that by 0.0412. And that gives us a z-score of 1.91. So now we're going to, it said at least, so that means greater than 1.91. Now, if you've got an older calculator, you have to do this. If you got a newer calculator, you would just say second vars, normal CDF, and instead of 0.19, we're going to do 1.91. Or newer calculator, you're going to do 0.27, 0.2667. 0.2667. And I think everything else is good, so paste. We got 0.0281, 2.81%, or 3%. Now let's check it with our other numbers. If you have an older calculator, second vars, normal CDF, and my z-score is 1.91 to infinity, 0 and 1. And let's see what the calculator gives us. 0.0281. So we checked it both ways, and we got 2.81% or 3%. So suppose a random sample of 90 school-age children results in 24 overweight children. What might you conclude? Well, you're talking about 3 people out of 100, 3%. And that's what we would expect to see, 3 people out of 100 resulting in a sample proportion of 27 or more. This is unusual simple sample if the true population is 0.188. And that's 8.2. Now, it's not very difficult, and we will go over some problems probably when y'all try the homework and send them in, unless you don't send them in, and therefore I don't know if you need any help or not. But that's always a good way to communicate with the teachers, not tell them when you have questions. That's a good way to communicate. closet. That's why you're going to be in a closet office, because you don't communicate. I was going to find the other, hold on a second. Well, everything logs me out so quick. 120.29. I was going to pull up 9.1. Nine point one. I'm just going to go over a few things. We only got like 20 minutes, but I'm just going to go over a few things. We're going to be talking about point estimate, and there's your P, X is equal to, P hat X over N. And in this case, here's another example of a question. This is a homework question from 8.2. Quinnipiac poll asked 1,783 voters whether they favor or oppose the death penalty. 1,123 were in favor. So P hat, I'm trying to find my, there we go. P hat is equal to 1,123 over 1,783. And let's do that on the calculator. 1,123 divided by 1,783. And P hat is 0.6298. Therefore, 1 minus second answer. Q hat is going to be equal to 0.3702. So that's chapter 8, 8.2. We just did 8.2 there on that homework question right there. I mean, on that example right there. And there it is, 0.63. We got 0.6298. Now, we're going to talk about confidence level. Confidence interval is unknown parameter consists of interval number based on a point estimate. A confidence interval is going to look like this. P hat is going to be between, let's go with 0.58 and 0.64. Now I made that up, but that's what a confidence interval looks like. This is a confidence interval. In other words, you're confident that your value is going to fall between 58 and 64%. That's what a confidence interval looks like. A confidence level is what tells us to make the confidence interval. The confidence level represents the expected proportion of intervals. In other words, if you can't have a confidence interval if you don't have a confidence level. The confidence level dictates the confidence interval. So you can't have a confidence interval if you don't have a confidence level. The confidence level is usually given. Question. It's usually given in the question. And we're going to get to the confidence level in just a minute. Okay, now this right here, this is where you start 9.1. Those previous slides, That was 8.2. But 9.1 is where you start with the confidence interval and confidence level. Talk about the confidence level, and I'm going to show you what you should need to work on for chapter 9. Need you to get an index card, one of those big index cards. And I need you to divide it up into several columns. Let's say this is your index card. And have a header up here. And then divide into several columns. 4 or 5. And we're going to start with, well, you can start here with 91 or 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. And that's called confidence level. Now, why did I start with 90 and why didn't I go to 100? Somebody tell me why I started with 90. Just take a normal, common sense guess why I started with 90. Why didn't I start with 67? Why did I start with 90? Y'all just aren't going to communicate with me, are you? Y'all want to give me a complex. I'm not going to be able to teach anymore because y'all giving me a complex. Why did I start with 90? What are we talking about? What are we talking about? What does that CONF mean?
Confidence.
Okay, why am I going to start with 90?
Well, it's kind of like 90 to 99 is like an interval, right? And then your next one would start at 100.
Yep. And what are we measuring?
The confidence.
Okay, so why am I starting with 90? You got to put yourself in a, let me rephrase it. You're in a job. You're getting paid money to do research. You've got to present to the board of directors in a week about the quality assurance of this facility. When you walk into that meeting, what do you want to walk in there with? I'm pointing at it. Somebody say it.
Confidence.
Okay, why did I start with 90? Okay, let me go through it again. Are you working for a company and you're being paid $70,000 a year to do quality assurance? You've got to go into a meeting and you've got to present before the board of directors of this company. What do you want to walk in there with? Confidence. Why did I start with 90? Why didn't I start with 52?
Because 90 is a high number? I don't know.
Exactly. You're right, Miss Cameron. You're exactly right. You don't want to walk in there, okay, I'm 52% confident. Duh. You want to walk into a meeting with at least 90% confidence. Why didn't I use 100?
You can't have more than 100% confidence.
Exactly. You cannot be perfect. You're not perfect. Okay? So you're not going to use 100 because that's perfect. All right? And you're not going to use 62 because you're not half-ass. Okay? You're going to use 90 to 100, 90 to 99. So most of your questions are going to deal with these confidence levels. Now, since your homework and your test grades are algorithmic and they change numbers, you will see some homework questions with 86 and 87. But I like to tell students they want to stick between 90 and 99 when you're talking about a confidence interval. So that's why I use 90 to 99, because you don't want to walk into a meeting. Okay, yes, sir, Mr. Director, I'm 87% confident. No, you don't. In fact, you don't want to go in there less than 95% confident. But in homework, they're going to use these numbers more than 95. So I tell students to make a index card and put 90 to 99. The next column will be called alpha. And that's going to be 1 minus 0.9 is equal to 0.1. 1 minus 0.91 is equal to 0.09. 1 minus 0.92 is 0.08. 1 minus 0.93 is 0.07, and so on. 1 minus 0.94 is 0.06. 0.04, 0.03, 0.02, 0.01. And that's alpha. Now you're going to do alpha over 2. What's a dime divided by 2? 0.05. I'm going to put this in 4 digits. What's half of 9 cents? 4.5 cents, Hubert. What's half of 8 cents? 4 cents, Hubert. What's half of 7 cents? 0.350. 0.0300. 0.0500. 0.0600. 0.0700. Oh, shoot. I messed up. I'm sorry. Point 0.025, 0.020, 0.0150, 0.0100, and 0.0050. And now your z-score, z sub alpha over 2. So let's take our handy dandy calculator, and I'm not going to do every one of these. This is what you need to do for homework tonight after you do 8.2 homework. Do second VARS, normal CDF, and lower is 0.0500, 0.0500. Wait a minute. Inverse norm. Sorry. Inverse norm. Second VARS, inverse norm. There we go. Oh, God. I hate it when it does this. I got to get out of everything. Second quit. Clear. There. Second VARS, inverse norm. There we go. Area is 0.05. 0, 0. And just hit left tail because you just want an area. It's 1.6. Technically, it's 1.645. 1.645. You're not worried about the sign. I'm going to do the first 5, and y'all can do the rest of them. Second, enter. And I'm going to type in 0.0450. Negative 1.695. 0.400 second. Let's see, 0.400. Enter. 1.75. I'm going to go down to 0.5. 0.0250. Oops. Second, enter. Crap. Second, enter. There. I'm going to do 0.0250. 0.0250. Negative 1.96 or 1.96. And I'm going to do 99%. Second. Sorry. I just messed that up. Second entry. Second entry. And I'm going to do 99% at 0.0050. 0.0050. And that gives me negative 2.58 or 2.58. Okay, so you need to work on tonight. You need to put this on your index card. And you just need 4 columns. You don't need this 5th column. You just need 4 columns. And you need to fill the rest of this in right here because I filled out all of this for you. All you need to do is 1, 2, 3, 4, 5. All you need to do is 5 more for the 1 or 2 people that's going to do this. Do this one, this one, this one, this. I'll tell you what. We got a few minutes. I'll just finish it. And that way, the 1 or 2 people that's going to do this, you won't have to do everything. Because I know most of y'all aren't going to do this. So 0.0350. 0.0350 is 1.81. You can do 1.812 if you wanted to. I'm just going to do 1.81. Second entry. Change it to 0300. 1.88. 0200. Negative 2 or 2.05. 0150. 2.17. And the last one, 2.33. So for the 1 or 2 that's actually going to do this, make sure you get a big index card. You make 4 columns. You call this confidence level, CL, alpha, alpha over 2, and Z sub alpha over 2. And you're going to be using that a good bit. And instead of having to figure it for each one, you'll have this index card. And when you get to a homework problem and it asks for a 95% confidence level, you know your 95% confidence level your Z is 1.96. Okay? And use an index card because you have the lines going across and you won't mess it up like I did, going uneven. That's why you use an index card. Okay, so we're going to stop right there. Your homework tonight is to work on 8.2, send questions, and then work on this. Get this done. Get that on an index card. Okay? All right, so I'm going to shut this down. Shut down the presentation, shut down the recording.